Hello, everyone. Just getting the live setup on TikTok and YouTube. How's it going, Ryan? Hopefully you can hear me. Hope everyone's doing well today. We're going to give everyone a few minutes to join before we get started. Hi, Bowser. It's my dog, Bowser. If you're joining on TikTok Live, make sure you also join on YouTube Live so that you can actually see my screen. As we go through practice problems, you can just search for Degree to PE on YouTube, and you should be able to see the live pop up on my page. But yeah, happy you guys can join. We'll be working through some fundamentals of engineering exam practice problems. If you weren't able to join yesterday, no worries. We're going to be going over these same problems. So yeah, glad everyone can join. Don't forget to drop your name and where you're from in the chat so that we can see who's joining us. Oops. People to close. Okay. Hi, Usain. Usually on Thursdays, I think we have a few more people join. Going to give everyone a few minutes before we get started. Don't forget to like the live and then also share this page with your civil engineering friends so that they also have access to the study material. On yesterday's live, I have posted the blank worksheet. You all can download that. I'm about to upload the answer key as well. But yeah, if you go to yesterday's live, in the description, you'll see the link to the blank worksheet. Yes, FE time. Thanks for joining. So today we will be going over the same practice problems that we went over yesterday. I didn't have time to put together a whole new practice set, so we're going to get really good at vector operations, construction, and transportation engineering. And then also, if you weren't here yesterday, We will not have these live sessions next week or the week after because your tutor will be out of the country for a couple weeks. So I will try to upload some worksheets that you all can work through, also some practice problem videos while I'm out of town. But yes, live will be canceled next week and the week after. But I'll be back at the end of September and ready to start up again. But yeah, I think we're going to go ahead and get started. Don't forget to drop your name and where you're from in the chat. If you're joining on TikTok Live, unfortunately, I'm not able to share my screen. So if you do want to see my screen as we work through practice problems, make sure that you join on YouTube Live. And yeah, I think that's pretty much it. If you guys don't know me, my name is Simone. I will be your tutor throughout this session. I am a professional engineer licensed in the state of Texas, and I started Degree to PE to basically just help my fellow engineers pass their FE and PE exam. So yeah, really happy you all can join. Um, there's been a lot of new followers joining the TikTok page, a lot of new subscribers to the YouTube page. So yeah, glad this is helping people. If you all have any suggestions, please feel free to let me know in the chat, or you can hit me up on LinkedIn, Instagram, TikTok, or YouTube. All right, but with that, I'm going to go ahead and get started. If you want to see my screen, make sure that you join on YouTube Live so that you can see the practice problems. But yeah, I'm gonna switch over my screen on YouTube so that you guys can see the practice problem. And again, if you joined yesterday, we're just going over the same practice problems that we did yesterday. So problem number 1 is a mathematics problem. It says a traffic signal is supported by a horizontal boom attached to a vertical pole. The signal has a weight of 300 newtons. The position vector from the pole's base point 0 to the signal is 406. So that would look something like this. The position vector just gives the direction. And then we're also given the force vector, and this should be negative 300 because the weight will be pulling the traffic signal downwards. So the question is asking us to determine the moment about point O. So in order to do that, we will need to do the cross product between the position vector and the force vector, because to get moments in 3D, you have to do the cross product. And just to let you guys know, the cross product is not a communicative vector operation. So make sure that you are crossing the position vector R by the force vector F. If you were to do it the opposite way, you're not going to get the same answer. So make sure that the position vector is first. So to do the cross product, you would end up with something like this. So M, the moment, would be the cross product of the position vector, which is just telling you the direction of the traffic signal from point O, and then the force vector is giving us the weight of the traffic signal. If we were to do this by hand, we basically have to do the determinant between those two vectors, which would look something like this. Then you're going to have your R1, R2, R3, your F1, F2, F3. And then you'd have to do some fancy calculations to get that value. And that's going to take you a long time on the FE exam. On the FE exam, the name of the game is speed. So what you can actually do instead of doing this by hand is you can just use your calculator. So on your calculator, I'm using the TI-36X Pro. For those of you on YouTube, this is what it looks like for those of you on TikTok. Um, so this calculator does do vector operations for you. All you have to do is tell the calculator what the vector values are, and then you just tell it to do whatever vector operation that you want it to do. So I'm going to go ahead and turn mine on. And remember, if you're joining on TikTok Live, thank you so much. I appreciate it. But in order to see my screen, you'll have to join on YouTube Live. So if you search for Degree to PE on YouTube, you should be able to find the channel and find the live so that you can actually see the practice problem. Just want to make sure you guys can follow along with us on YouTube. So yeah. So back to the calculator. If you press the second button, this blue button here in the top left of the calculator, you press the second button and you go and you hit the double E. The double E. Above that, it says vector. So it will bring up your vector screen. So the first column is the name of the vector. The second column is the math operation column. And then the last column is edit, which is where you can edit the vectors that are currently in your calculator. So I'm going to go to edit and I'm going to select vector U. And these are three-dimensional vectors. So I'm going to go ahead and tell the calculator that it's a three-dimensional vector. I'm going to hit enter, hit OK. So right now it just says 0, 0, 0, but we are about to input the position vector R. So this first value needs to be a 4. So I'm just going to type 4, hit enter. We don't have a J value for this vector, so I'm going to leave that as 0 and hit enter. And then for the last value, I'm going to input 6, hit enter, and then I'm going to hit clear a couple of times to get back to the home screen. Hopefully you guys are all following along there. I'm going to hit second again, go to vector. I'm going to edit vector V now. I'm going to tell the calculator it's 3 dimensions, hit OK. So the first two values will be 0, but this last value is going to be negative 300 to represent the weight of the traffic signal, the negative 300 newtons. All right, I'm going to hit clear a couple of times, hit second, hit vector. So now that we've input the two vectors into our calculator, and this should not take you long as you practice before the exam. Now I'm going to go to the math column. I'm going to go down to 2, which is the cross product. Hopefully you all can see that. So I'm telling the calculator to do the cross product and then, oops. This is what your screen should look like once you hit cross product. So to tell the calculator to do the cross product between vectors U and V, you'll need to go to second vector, and in the names column, you'll hit vector U. Put a comma by hitting second and this period down here. And then again, go back to the vector column under names. I'm going to go to 2, hit enter. So I'm telling the calculator to do the cross product for vectors U and V. I'm going to close the parentheses, hit enter, and the result of the cross product is going to be another vector. Because if you all remember from statics, if you have two vectors on a certain plane, the cross product is actually going to be a vector that's perpendicular to that plane. So we have a vector of 0, 1200, 0. So this 1200 is going to be the moment of the force about 0.0. So our answer is going to be 1200 Newton meters. Don't forget that moment is a force times the distance, so your units need to reflect that. So in this case, it's going to be a Newton meter. And yeah, that is our answer. So if you practice using your calculator before the FE exam, it can save you a lot of time. On the FE exam, you're only going to have about 3 minutes per question. You obviously don't want to use 3 minutes on all the questions because you want to have time to be able to go back and check your work or go back to problems that you flag. So yeah, In under a minute, you would be able to solve this problem if you use your calculator. If you try to do it by hand, it's going to take you probably those 3 minutes. So just keep that in mind. You want to be as efficient as possible. So that is all for the first problem. If there are no questions on that, if you're joining on TikTok Live, just a reminder to hop over to YouTube so that you can actually see the practice problems on my screen. You can just search for degree to PE and you should be able to see the live pop-up. But yeah, this is FE exam study session number 8. So happy to have you all joining. But yeah, we're going to move on to practice problem number 2. Just going to show everyone on TikTok my screen. So if you join on YouTube, you should be able to see this. So practice problem number 2 is going to be another mathematics problem. This question is asking us to find the angle between two vectors, G and H. So if you're following along, hopefully you have your FE reference manual in front of you, because let's say you forgot how to find the angle between two vectors. If you search your FE reference handbook, it is a searchable PDF. You can search for, let's do vector, see what comes up. So if you search for vector, you should come to this section here under mathematics, and it gives you a whole bunch of handy dandy formulas that you'll need on the FE exam. So we are going to be doing the dot product because we can see when we perform the dot product between two vectors, it's going to be equal to the magnitude of both vectors times the cosine of the angle between them, which is what the question is asking for. So that's what we're going to go ahead and do. Let me go back to the study session. So like we just looked up the dot product formula, just going to write that here. It says that when you perform this vector operation, you should get the magnitude of the first vector times the magnitude of the second vector times the cosine of the angle between those two vectors. You're just like we did in the first problem, we can also have our calculator perform the dot product. So I'm going to go ahead and edit the vectors that we put in the calculator. So going back to the edit column, I'm going to edit vector u. These are two-dimensional vectors because we are only seeing I and j components, which represent the x and y coordinates. So telling the calculator it's a two-dimensional vector. The first value, g, is going to be vector u, so the first value should be -5. Hit enter. Second value should be 5. Hit enter. I'm going to go back and edit vector v now. Also need to tell the calculator that it is 2 dimensions instead of 3. Hit OK. First value is going to be a +2. Second value is going to be a +3. Hit clear a couple of times. Hit the second button, vector. Now we're going to have it do the math for us. So if we go to the math column, number 1 says dot product, which is what we want. So I'm going to hit enter and input those two vectors by hitting second, going to the names column, selecting the first one, comma, select V. This is really hard to do backwards. Ooh. Okay, then I'm going to close the parentheses, hit enter. Your result should be a scalar value. So the calculator is telling us the dot product results in the number 5. So that was a really quick way to do the dot product. Otherwise, you would have to do it by hand, which could take you longer, and it just also is an area where there could be some human error. So we're just using our calculator to make things easier. Our calculator told us the answer was 5. So now that we know what the dot product result is. We also need to find the magnitudes of G and H. So to do that, we need to take the square root of the component squared, just like the Pythagorean theorem. So we're going to do -5 squared plus 5 squared. And feel free to type that in on your calculator and put it in the chat what you get for the answer. I'm going to go ahead and write out the magnitude of H as well. It's going to be the square root of 2 squared plus 3 squared. So feel free to put the answers in the chat if you have them. So the magnitude of G, I got 5 root 2. For the magnitude of H, I got the square root of 13. So yeah, now we can plug these into the formula. So we're going to have 5 root 2 times the square root of 13 times the cosine of theta equals 5. Hopefully you all are following along. Let me know if you have any questions. I'll be sure to answer those. So now that we have the equation set up, we're just solving for theta. So divide both sides by the magnitude of the vectors. You should get cosine of theta equals 0.196. Let me know if you're getting anything different. And then you're just going to do the cosine inverse of 0.196. And on your calculator to do that, if you press the cosine button twice, it should give you the inverse function of cosine. So I'm just putting in 0.196. So I'm getting theta. Scroll down just a tad. Theta equals 78.7 degrees. I'm going to do it in a different color so it's clear. So theta equals 78.7 degrees. And just to let y'all know, the link to the blank worksheet and the answer key will be posted after this live ends, so keep a lookout for that. If you want yesterday's worksheet and answer key, it's going to be the same thing, so you can also go to that video to find those items. Should be linked in the description. All right, so that's it for problem number 2. So we got some good vector operation practice in. We did the cross product and we did the dot product. I will be posting a statics review video shortly, hopefully before I go out of town. But yeah, if you're a little fuzzy on dot product or cross product or vectors, that video will go in depth a little bit more. Thank you guys for liking the live. Really appreciate it. Okay, so moving on to problem number 3, if you all don't have any questions about 1 or 2. All right, so problem number 3 is a construction engineering problem. We hadn't done this in previous weeks, so just wanted to make sure that we're hitting all the topics that you could encounter on the FE exam. So construction, it says determine the critical path of the project schedule seen below in days. So shown on the screen is a construction project schedule, and we're being asked to determine what the critical path is. The critical path is going to be the longest path between the start task, A, and the end task, which is H. So whatever pathway has the most amount of days will be the critical path. If you guys are joining on TikTok Live, you can go ahead and join on YouTube Live. TikTok doesn't let me share my screen. So this is what the practice problem looks like that we're doing right now. If you search on YouTube, degree to PE, you should be able to see the live come up. And then on that live stream, you'll be able to actually see the practice problem as I go through it. But yeah, just want to make sure you guys have somewhere you can follow along. All right. So, uh, can anyone tell me what pathway can get you from A to H? Anyone have any ideas about that? Feel free to put it in the chat. There are no stupid answers, so this is a safe space to practice. So I'm seeing that one pathway we can take is A to, oh, don't want to erase. We can go from A to B. We can then go from B to D, and we can go from D to H. So I'm just going to add all of those task durations up. So that would be A, B, D, E. We would get 5 plus 7 plus 3 plus 2. And let me move my face. So 5 plus 7 plus 3 plus 2 is going to give us 17 days. All right. Let's see what other pathway we can take. We could also go from A to B, B to E, E to G, and G to H. So let's add up how many days that would be. So that would be 5 plus 7 plus 9 plus 8 plus 2. And again, if you're following along, feel free to put the answer in the chat. I can make mistakes, so feel free to let me know if I'm making an error somewhere. But 5 plus 7 is going to be 12. 12 plus 9 is going to be 21. 21 plus 8 is going to be 29. 29 plus 2 is going to be 31 days. So if we took the second path, it would be 31 days. Okay. And then the last path that we could take is A to C. Oops. A to C, C to F, F to G, and G to H. So A, C, F, G, H. We want to add up those days together. So we would get 5 plus 4 plus 6 plus 8 plus 2. And just quick mental math here. 5 plus 4 is 9. 9 plus 6 is 15. 15 plus 8 is 23. 23 plus 2 is 25 days. So out of all the pathways that we took, the longest was the second option of 31 days. So that means our critical path is 31 days. So scheduling is very important in civil engineering. You use it on the construction side. I'm on the design side of the house, and we do project schedules all the time to make sure that the project stays on budget and is completed by the date it needs to be completed by. Even though we don't typically have schedules that look like this, we typically use a program called Microsoft Project. So if you do have the opportunity to learn Microsoft Project in school, or let's just say you have some free time to do it on LinkedIn Learning, I highly recommend that be a program that you try to learn. It's very helpful, and it can calculate things for you like critical path. But yeah, that is all for problem number 3. Does anyone have any questions on that? And if you're joining on TikTok Live, this is what the problem looks like. You can join on YouTube so you can actually see my screen as I work through the problem. but unfortunately on TikTok, it doesn't let me share my screen. But yeah, that's all for problem number 3. No questions? All right, we'll move on to the last problem I have for you guys today, which is a transportation engineering problem. So problem number 4 says, find the maximum flow rate of the highway, use level of service B and a speed of 60 miles per hour. If you read that problem and you have no idea where to start, just search your FE reference manual. That's what I'm going to do. So the question is asking us to determine the maximum flow of a highway. So I'm going to search for, uh, I'm not going to search for maximum flow because maximum flow could be in a lot of different categories. So I will say highway. I'm going to search for highway and see what comes up. So we have vertical curves. It's not a vertical curve problem. Okay, so that brought me to the highway capacity. So let's see if we can find something helpful in here. Okay, so now I'm in the traffic flow relations section of the FE reference manual. If you're joining on YouTube, I hope you can see this. So yeah, using the green shields model, we are going to solve for the maximum flow that we can have on this highway using the equations given. So if you're joining on TikTok, thank you. But in order to see my screen, you'll have to join on YouTube Live. This is what we're doing. We are finding the maximum flow of a highway. Thank you guys for liking the live. Appreciate it. Okay. So I'm just going to grab those formulas so that we have them. Let me try that again. Okay, so here are the formulas. I'm going to copy and paste them over into our session. And then I'm also going to paste what all of these variables mean because just looking at it, it could be very confusing. So I'm just going to copy and paste this section. Copy. Go back and paste. So I got all of this information from the reference manual. So make sure you're practicing with the reference manual so you get faster and you know what formulas are in there and how to search, where to search for this information. So that's kind of big. Let me move it. Okay, looking good there. And then one more thing I saw that we'll need is this level of service table. So I'm also going to go ahead and copy and paste that over. Okay, so we should have all the information that we need now. So yeah, let's go ahead and get started. So we are being asked to find the maximum flow rate of the highway. So if you look at all these equations here, maximum flow rate is V sub m. So we are trying to solve for Vm. That's what we're trying to find. But in order to find Vm, we'll need to find dj. dj is going to be the jam density here. And we're also going to need the theoretical speed, SF. We'll multiply those together and we will divide it by 4 to find the maximum flow rate of the highway. But how do we find the jam density? To find the jam density, we are going to use this last equation right here. So to find DO, which is optimum density, we're going to go ahead and look at our level of service table. The problem tells us that our highway has a level of service B. That is a very big highlight. Let me make that smaller. Actually, I'll move this down here. Okay, so we are in level of service B, which gives us, in this table, gives us a range of densities. But because the question is asking for the maximum flow rate of the highway, we're going to use the maximum density that we can have in level of service B, which is going to be 18 cars per mile per lane. All right, so does that make sense to everyone how we found DO, the optimum density? Hey, Ramveer, thanks for joining on YouTube. We are on practice problem number 4. All right, so DO, so we're going to use 18 for DO. So DO, let me make sure I'm not overlapping my face. Yes. So DO equals 18 cars per mile per lane. So now that we have DO, we can find DJ. So DJ, if we solve for this last equation, we're just going to get DJ equals 2 times DO, which means it's going to be 36 cars per mile per lane. So that is the jam density, which I believe would be the density if, the highway was jammed. Rush hour traffic, basically. Okay, so we found DJ. So we solved for that. I'm going to put a check mark there. Now we need to find the theoretical speed. So to find the theoretical speed, we are going to use this first equation right here. So the first equation says that the speed of the highway is equal to the theoretical speed minus the theoretical speed divided by the jam density. For some reason, it is really hard for me to say that. Jam density. Okay, and then we're going to multiply that by the optimum density. So I'm just going to go ahead and write this out. So S equals, we're trying to solve for SF. That is the value we do not know. But we have all these other values. So if I plug in the numbers that we already have from the problem, we're going to get 60 equals SF minus SF divided by the jam density. I did it that time. The jam, oh my gosh, I just messed it up again. I keep saying jam density. Jam density. Okay. Divided by DJ. That's what I'm going to call it. So we found DJ to be 36. And then this last D here is going to be the optimum density. So we're going to multiply that by 18. Any questions about that so far? If you're joining on TikTok, this is what the practice problem looks like, but you'll have to join on YouTube Live if you want to see my screen. So feel free to hop over to YouTube, type in degree to PE, and you should be able to find the channel and the live stream. But just want to make sure you guys can follow along. So now we're just going to solve for SF. And if you do solve for SF, you should get 60 equals 0.5 SF, which means SF equals, yes, 1 second, 18 divided by 36. Yep, okay. All right, so 60 divided by 0.5 should get 120. SF equals 120 miles per hour. All right, so we solved for all the variables that we'll need to solve for the maximum flow rate of the highway. So I'm just going to scroll down a little bit so we can finish out this problem. So we're trying to find VM, which is going to be equal to the jam density times the theoretical speed divided by 4. So that's going to be equal to 36. We found that up here. We found DJ to be 36. We found the theoretical speed to be 120 miles per hour right here. And then we're going to divide those two values by 4. And feel free to put in the chat what you get for your answer. It's really good practice to make sure that you also know how to do the problem. So feel free to put the answer in the chat. Let me know what you get. But I'm getting the maximum flow of the highway is 1,080 vehicles per hour. And that is it for practice problem number 4. So yeah, that is all I have for you guys today. Does anyone have any questions about any of the practice problems that we went over on TikTok or YouTube? Feel free to let me know if you have any questions. We also have quite a bit of time left, so let me know if you want me to do any more practice problems. If you missed anything, you can always search for Degree to PE on YouTube and see all the previous lives that I've done. I'm also in the process of linking all of the blank worksheets and the answer keys to all of the live videos. So if you missed, this is our 8th live session. So if you've missed any between 1 and 8, you can always go back and rewatch those. And then once I link the worksheets, you'll be able to download those for free as well. Hey Maggie. I go live Wednesdays and Thursdays from 3 to 4 p.m. Central Standard Time. This is our 8th live session. However, I will be going out of town for the next 2 weeks, so the class will be canceled for the next 2 weeks. But at the end of September, I will be back and ready to go. So there is a link that you can use to submit practice problems that you want me to go over. So if you just look a couple videos down on my page, you should see that link. It's just a Google form. So yeah, if there are any practice problems that are giving you all trouble, you can submit them there. Let me check actually to see if anyone submitted any. Still no submissions. So yeah, just to let y'all know, also let your friends know if they have any practice problems they're struggling with, they can submit them and I will do them on these lives. But yeah, any other questions? Cool, cool. I will also be posting a statics model here soon. So that YouTube video is going to go over everything you need to know about statics. And then throughout the video, we'll be going through some practice problems. So yeah, if you guys want to see what that's looking like, I can actually show you. So this is just going to be a full statics review. So just going over things like vector operations, unit vectors, dot product, which we just did, cross product, which we also just went over. Let's see, equilibrium and free body diagrams. We'll be talking about tension, weight, members in compression, members in tension, support reactions. Here are some common ones that you'll likely see. Pulleys, cables, ropes, wires, springs. We have some example problems. We'll be going over moments, types of loads, distributive loads, triangular loads, and then how to solve equilibrium problems, which I guarantee you will find, or you will get an equilibrium problem on the FE exam. So you want to make sure that you are comfortable with that topic. But yeah, this is what it's looking like. I'm really excited to post this video for y'all. These videos are taking me a bit longer than I thought they would, but there's a lot of information that goes into the FE exam. The FE exam is basically just going over your entire undergrad degree. So yeah, I'll be making videos for each topic that you could possibly encounter on the FE exam. I've already posted a video about everything you need to know about the FE exam, so feel free to watch that on YouTube. I'm going to keep posting practice problems here on TikTok and YouTube as well. But yeah, I'm happy you all could join. If there are no other questions, I'm going to log off. Thank you guys for the gifts and liking the live. I really appreciate it. Yes, see you at the end of September. But yeah, I'll be back and full force. So feel free to watch my previous lives while I'm out of town. But yeah, that's all I got for you guys today. I will see you guys at the end of September. Bye.